Hello and welcome to today's video on black holes. Have you ever wondered why black holes can stretch and distort space and time? And do you know how many types of black holes are there, or if objects can escape from the gravitational pull of a black hole or not? If you don't know, then there's no need to be worried because we will learn about all of this in today's video. So let's get started. First of all, we need to have a good understanding of what a black hole is and how is it formed. Black holes are some of the most mysterious and fascinating objects in the universe. They are formed when a massive object, such as a star, collapses in on itself. But did you know that they can be formed in other ways, such as through the collision and merging of two smaller black holes? Black holes are not really holes in the traditional sense, but rather extremely dense regions of space where the normal laws of physics break down. In simple words, black holes are extremely dense objects in space that have a very strong gravitational pull. This means that they can pull in anything that gets too close to them, including light and other objects. Now we know what black holes are and how are they formed. Let's see how many types of black holes are there. There are three main types of black holes: stellar black holes, intermediate mass black holes, and supermassive black holes. Stellar black holes are the most common type and are formed when a massive star collapses at the end of its life. They can range in size from a few times the mass of the Sun to tens of times the mass of the Sun. Intermediate mass black holes are thought to be black holes with masses between 100 and 100,000 times the mass of the Sun. They may be formed from the merging of smaller black holes, or they may be the remnants of very massive stars that have collapsed. Supermassive black holes are the largest type of black hole, with masses that can range from millions to billions of times the mass of the Sun. They are thought to be at the center of most galaxies, including our own Milky Way. Now let's see if objects can escape from the gravitational pull of a black hole or not. So according to different researches, it is possible for objects to escape the gravitational pull of a black hole, but it requires a tremendous amount of energy. The gravitational pull of a black hole is extremely strong, and once an object crosses the boundary of the black hole, called the event horizon, it is unable to escape. However, objects that are outside of the event horizon may be able to escape the black hole's gravitational pull if they are moving fast enough. In order to escape the gravitational pull of a black hole, an object would need to be moving at a speed known as the escape velocity. This is the minimum speed required for an object to break free from the gravitational pull of a celestial body and continue moving away from it. For a black hole, the escape velocity is equal to the speed of light. This means that in order to escape the gravitational pull of a black hole, an object would need to be moving at the speed of light or faster. This is an enormous amount of energy, and it is currently beyond our technological capabilities to achieve. It is worth noting that while it is theoretically possible for objects to escape the gravitational pull of a black hole, it is highly unlikely in practice due to the extreme conditions required. Now let's know why black holes are able to stretch and distort space and time. Black holes are able to stretch and distort space and time, also known as spacetime, due to their extremely strong gravitational pull. The gravitational pull of a black hole is caused by its mass, and the more massive an object is, the stronger its gravitational pull will be. As we know that black holes are some of the most massive objects in the universe, with the largest ones having masses that can range from millions to billions of times the mass of the Sun. As a result, the gravitational pull of a black hole is extremely strong, and it can stretch and distort spacetime in its vicinity. This effect is known as spacetime curvature. The degree to which spacetime is stretched and distorted by a black hole depends on its mass and size, as well as the distance of an object from the black hole. The closer an object is to the black hole, the more strongly it will feel the gravitational pull, and the more spacetime will be stretched and distorted. Overall, the stretching and distortion of spacetime by a black hole is an important aspect of its behavior and properties, and it is one of the many mysteries surrounding these mysterious objects that scientists continue to study. Black holes continue to captivate the imagination of scientists and the general public alike, and there is still much we don't know about these mysterious objects. Thank you for watching today's video on black holes. If you have any questions or want to learn more, leave a comment below and we'll be happy to help. If you find this video useful, please consider subscribing our channel for more informative videos.